Hello everyone, today we will talk about tree data structure. This video will set the foundation for the trees which we will use to solve more advanced tree questions. You might be familiar with the other data structures. In this case, if we see array, linked list, stacks and queues. All of these data structures have a logical start to it and a logical end to end, right? That's why these data structures are called linear data structures. Tree does not have a logical start or logical end to it. That's why tree is called a non-linear data structure. Tree is used to mostly represent the hierarchy data structure. For example, here we have a fictional company where John is the CEO. For John, have a two direct reportees who is Ron as well as Jack. Both of those are VP and those are direct reportees to John. In turn, Ron have a Harry and Patrick reporting to him. Similarly, for Jack, we have Bob and Beth reporting to him. If you see, this is a fictional company and we are able to represent the complete hierarchy of a company. So this is a kind of example where we can use tree for a data structure. Similarly, the files that we store in our operating system are stored in a tree data structure. Before we deep dive into the tree, let's talk about different terminologies that we might use in this video and the later videos based onto the tree. First of all, node in a tree is a vertex of the root. Vertex is a concept that we are drawing from the graph. If we consider this tree, then 1, 2, 3, 4, 5, all of these are the nodes to the tree. Please, 1, 2, 3 is just the numbers that I have given to identify it. We will talk about the complete structure of nodes later on. Now, if you look closely, for this particular node 1, we have two connections to it, which is going outwards from 1, which is 2 and to the 3. In this case, 1 is considered as the parent and 2 and 3 will be considered as the child of node 1, right? Similarly, for this particular node 2, 4 and 5 are the children. However, 2 is a parent to 4 and 5. Same goes with the other nodes in the tree as well. The nodes who share the same parent are called the siblings. So in this case, 2 and 3 share the same parent as 2, so 2 and 3 are the siblings. Similarly, 4 and 5 share the same parent which is 2, so 4 and 5 are the siblings. Similarly, 6, 7 and 8 share the same parent which is 3, that's why 6, 7 and 8 are considered to be the siblings. Any node which has a parent as well as children is considered as an internal node. Here 2 is an internal node. Similarly, 3 is an internal node, 6 is an internal node, 8 is an internal node. However, if we consider 9, 10 and 11, this does not have a children's to it. In this case, any node which does not have a children to it are called as leaf nodes. Now, root is a special type of node. It does have a children to it, but it does not have a parent to it. That's why any node that does not have a parent to it and it has a children is called as root. For any particular tree, there will be only one root. Root is a very important node for us. Anything, we actually get a pointer to the root and from there we need to iterate or do whatever operation we have to do for that particular tree. So root is a node which does not have a parent, but we will always get a pointer to the root node. Ancestor of a node is all the parents from that node till the root. For example, if we consider 9, the 9's parent is 4, 4's parent is 2, and 2's parent is 1. In that case, all of these 1, 2, and 4 are ancestor to the node 9. Similarly, descendants are the nodes which are the children to its children. It's kind of a great great grandfather to the great grandson kind of relationship. Here, if we see 1 as a root node, from 1, 2 is the children, 4 is the children, 9 is the children. In this case, all the nodes till this side are the descendants of the node 1. Similarly, for node 3, the descendants will be 6, 7, 8 and all the children of 6, 7, 8. So all of these are the descendant of the node 3. Apart from all of this, one more important concept is the links or the edges. So if you see, there is an outward connection from the parent node to its child node. This outward connection itself is called as link or the edges. So that was mostly about the terminologies about the trees. One more important concept about tree is a tree is a recursive data structure. I have seen students making lot of confusion when we talk about tree as a recursive data structure. For example, if we consider a tree with a root node 1, we have the two children to that. The left children will be the 2 and the right children will be the 3. If we see closely, 2 and 3 in turns are the trees itself. If we consider the tree starting from 2 and the tree starting from 3, then this will become a subtree itself. Going deeper into that, for 2, 4 and 5 are the subtrees as well. Similarly, for 3, 6 and 8 are the subtrees itself. So with this we can see the tree is a recursive data structure where the left side will be the left subtree, right side will be the right subtree. I am using this left subtree, right subtree as a concept from the binary trees. Let's talk about that as well. Now, in case the tree is not a binary tree, then we might have one more subtree here, but you get the idea. Any any children to a particular node will create its own subtree itself. That's why this all is called as a recursive data structure. We will use this property of a recursive data structure very intensively while we solve the tree problems. Before we wind up this video, let's talk about a special type of tree which is called as binary tree. Binary tree is a tree where every node in the tree will have less than or equal to two nodes. So if we take an example of these trees, here the root node 1 have two childrens which is again less than 2. Similarly for 2 we have two childrens. If we consider 4 as a root node, for 4 we have 0 childrens, right? So this again conforms to this particular property. So this is a binary tree. In case of this tree, here we have 1 has two children which is again less than 2, 2 has only one children which is less than 2 and 5 has no children. So considering all of the nodes in this tree conforms to this particular property, that's why this tree is a binary tree. However, if we consider this particular tree here, in case of a node 4, we have 3 children to that. So since this has a 3 children, it does not conform to this property. That's why this tree is not a binary tree. Most of our questions that will be based on a tree will be onto the binary tree. So please understand this particular property for this. This will be very useful in our later part. The code for a tree in Java will look something like this. You can use the similar concepts in other languages as well, but for illustration I have used Java here. So here we are saying tree node as a class that we have created. Here the integer value will be the value of that particular node. The left is to the left subchild and right is the right child. Now if you remember, in a binary tree there can be either 0, 1 or 2 children. Children has to be less than 2. In this case we can only have these two as a possibilities. So there will be left or right child. Now these two are the constructors. In case if we have given only value, then the tree node will be created with a value. In case we have given a left and right, then this will be how our tree will look like. So that's it for this video. In the next video we will talk about height of a tree or maximum depth of a tree? This question gets asked a lot into interviews, so I would highly suggest to check out this video as well. That's it for this video. Thanks for watching.